experimentation and doing quick hacks and sort of seeing if things are working or not. If you're using a compiled language like Java, then this tends to take a long sort of cycle between writing the code, compiling it, running it. But with Python, you can sort of do this quickly. And so it gets used quite a lot. It's also very easy to learn and has a million libraries that you can use for all sorts of things. So that's why we use Python. Jupyter is sort of this thing here. So you can do, ordinarily, if you're programming, you sort of have an IDE or some Notepad++ or something. You write your script, then you go to some command line and run the script and etc. With Jupyter, you can do all this stuff in this sort of web browser thing. And so you should have this. If you have Anaconda, this is automatically installed for you. So Anaconda installs for you Python, Jupyter Notebook, installs for you Matplotlib, all the libraries we sort of want to use, NumPy, etc. All right. So we're going to, if you have these notebooks, or if you've opened up a notebook, we're going to sort of go through basic things in Python. Who hasn't, who needs to learn Python, or who doesn't have an idea about Python? A good number. A good number what? It's a good number, period. Okay, so, all right, so I'll just sort of talk through an introduction, and you can follow this if you open up a notebook. The way to open up a notebook, I think in Windows, is to click Start, I think, go to Anaconda, and then click Jupyter Notebook, right? Can someone with Windows computer confirm? That's right? There you go. So if you open up a notebook, it should be some blank thing like this. And you can sort of go to New and start a blank notebook. Right? And you can give it any sort of title. So what this helps is you can, so the Jupyter sort of interface, maybe I should explain it, is, so it's based on cells. So you have these things called cells, and you can add cells as you go down, and each sort of code you write is in a cell, and you can execute the cell and move on. And in the cell, you can do one of two things. You can either write code, right? So this is a print statement in Python. You can either write code or you can write some sort of text, markdown. And you can change from code, or you can go to markdown, or it can be heading or whatever. Normally you change from code and markdown. And then once you run the cell, so you only run a cell at a time. And you can move them around. It's really flexible. So what you can do with Jupyter is you can document your code. You can sort of write a whole sentence here about the code you're going to write, and sort of have the sentence, and then you can write your code, and you can. The beauty with this is you see the results immediately, but you can also change. You can change your inputs and get different outputs. So you can sort of iterate through any process you're going through. All right. And you can have several notebooks. So this is just how this is done. And you can do all sorts of. So all these are cells. Right. Oh, image is not there. All right, so if you want a quick introduction to Jupyter, and you can also change the kernel. You can change depending on what you want. So for example, on my system, I have Python 2 and Python 3 and a bunch of other sort of environments. And you can sort of switch between environments here. If you want a quick tour of Notebook, you can sort of go to help and click this user interactive tour. It gives you an interactive tour of several of the things. You sort of have to click on the thing and shows you all sorts of areas on the notebook that you can do stuff. All right, so that's it with Jupyter, unless someone has a really burning question on how we use Jupyter. Less burning questions? Purely cold questions? Yeah, purely cold question. Yes, sir. Yeah, they will just run fine. So if you have different versions of Python, you probably have, so you can see this thing here sort of tells you which version of Python you're running. And you can change the versions just by going here, go to change kernel, and you can change between 2, 3, or 5. But with the notebooks we are going to run during this data science summer school, I think most of them are Python 3. So Python is now versioned up to version 3, I think 3.6 maybe. But any version after 3 is good. So 3.5, 3.6. Okay. And you can check your version by doing this thing. So you can actually run command line sort of commands in Jupyter by using this shebang. Is it called a shebang? Exclamation mark. All right, so we'll begin with an introduction of Python, and then hopefully introduce some NumPy, which is an important sort of library, and then do some plotting, see how data works in Python and NumPy, and then hopefully finish in a short while. I don't know how much time we have. Okay, we have time. All right, so if you've opened up a notebook, you can sort of follow along these commands here if they're clear. Yes? Right, so oh yeah, well, Mike, are we anywhere? Yeah, so you have to wait, still copying. But what you can do, this is really, so we can do it on a, if you open up a new notebook, you can just follow along and do the stuff I'm going to do. It's not complicated. You don't need this stuff. This stuff is for, yeah. I mean, so you have basic types. So we can even do it here. So you can follow along. So you have, in Python, you can sort of, yes, a little bigger. Is that big enough? So you can sort of write, you can do any sort of addition, any sort of numerical calculation on the prompt. And if you click run, it sort of gives you the value. So there's not much there. So you have basic types. I mean, you can do anything. Yeah, well, to get the exponential, you can do things like 2 squared. Sort of squared is like that. So you can do anything basic in numbers, typing in things. You can also have a string. So strings are just the normal strings. You can, so one thing with the one other advantage with the Jupyter Notebook is that you can, if you've forgotten a method, or if you want to see what methods I can apply in a string, like this string A, I can put the dot, and if I do a shift tab, it gives me, oh well, no, this, maybe not this one. Okay, I can do something like dr a directory of A. It gives me all the methods that I can apply to this string. So A is a string. And you can do, so the methods that really matter are sort of down here. So you can do things like starts with, split, translate, upper. So I can do something like, and then that will, you know, or lower. You can do all sorts of things with text. You can split it up. You can see whether it starts with some sort of letter, you know, or not. So you can do all sorts of things with these methods. So one of the, so that's a key thing with the Jupyter Note. The Shift tab gives you a lot of insight into the methods. All right, and you can sort of follow along with other sort of basic types. There are Boolean types. You can sort of compare things the normal way you compare them in most other languages. Right. And you can concatenate strings with the plus, so you can add strings together with plus, and then you get all sorts of things. All right, so basic data structures, so basic containers in Python. You have things like lists. So lists can contain any type of object. So it can contain integers or strings or other lists or all sorts of things, right? So you can sort of print them out. And you can have also slicing in lists. So if you can, are you following? Are you typing this? You should be typing this if it's not the usual thing you do. Yeah, so you can split this string. So I can create a list by splitting this string. And if I split it, then B looks something like this. You can, you know, it splits this string based on empty space on these spaces. So this gives you something like a string, a list of all the different words in this string. Yes. Are you running them? Are you pressing the? Is there an error? So you need shift. Oh, what I'm doing, I'm shifting enter. When I do shift enter, all right. There was a. Yeah, those who don't have Jupyter Notebook, there are flash drives. Yeah. All right, so as I said, the list can be of any sort of thing. And again, with these lists, you can sort of, if you want to see what sort of methods you can apply to a list, You can sort of see, you can append to a list, you can clear the list, you can copy, you can count items in a list, you can extend a list, you can pop, remove, reverse. You can do many things with the list. Right? You can sort the list. Right? So the list you can have many sort of things you can do with this list. One other thing, maybe a bit of slicing, is Python is a zero-based, sort of you start counting from zero. And use these sort of square brackets to get elements. So for example, the first element in this list is identified by this zero index. Right? And can go on, so this would be number 4. 0, 1, 2, 3, 4. And you can do some fancy slicing as well. You can do some so basically the slicing follows a sort of you sort of start, then you have a colon where you stop, and then you have a step. Right? This is basically how slicing works. Yeah. Oh. Ah. Okay. Okay. Sorry. So the way you run a cell is to. Right now I'm doing a shift enter, but you can also go here and press enter. It's the same as sort of running the cell. So as I said, Jupyter is a cell-based thing, so it only runs the cell at a time. And these numbers here in the bracket sort of give you the order of running the cells. So I can sort of see I run 13, 16, 18 is the latest I run. I can run this again, B20. So you have to run the cell, especially if it's code. So normally most of the cells are code, unless you convert it into. If the cell, for example, now is markdown, then it's a slightly different thing. If it's code, then it runs the code. Any other confusion about cells? Have you sort of written this thing down? I would love for you to write this thing down, because this is Data Science Africa. Right, so if you can write it and sort of just take one moment to look at the methods and try and run one of the methods. So for example, on the list, you can sort of do this thing with and sort of get a method down here and try and run one method on this list and see if it sort of works. Give you an idea of what you can do with lists. Anyone lost? Yes, Andrew. The minus, this. Right. Okay, so you can, so this indexing is sort of, so we said it starts from 0. When you say 0, it sort of starts, this is 0, 1, 2, 3, 4. The negative 1 is sort of starting from the other side. So if it's negative 1 here, well, negative 11, then it will be starting from here. So this is negative 1, negative 2. Negative 3 will be this. Right? So it gives you a way of indexing your list or your array starting from. Negative 6. Someone wants negative 6. What will happen if we type negative 6 here? We'll get an? We'll get Neil's stuff that he presented earlier. All right, no we don't, sorry. So we get an error because the index is out of range. So this is a common error, index error. So when you're doing manipulations, you will normally get this error. If you do, just make sure your indexing is right. It's a common error. And then, so indexing does, you can sort of start from -3. As I said, indexing sort of uses this thing. Oh, and this is a comment. So I can comment out things like this using a normal Python comment. So this thing doesn't run because it's commented out. But you can sort of start, then you have a full colon, stop. So I can start at -3, go on up to -4. And then I'll get nothing, unfortunately. Oh, how do I get nothing? Oh, -3. All right, so I can sort of start at -3 and index going that side. So what this does here is, so all these things are optional. A lot of them are optional. So I can have, what this means is give me everything. Start with the last thing, end at the last thing, and start sort of going back. Do a step of -1. So it basically starts going back the other way around, and so you get a reverse. So this thing here is a total reverse of this. Right? It's like inverting the list. And you can do things like give me a step of 2, so it gives you this and skips, gives you this, skips and gives you this. So you can actually step through. That's what the step means. You can step through the array. And you can delete a cell. You can delete a cell. Where's the delete? I know the shortcut, but edit, delete cell. All right, let's go on. So you have other sort of containers. You have dictionaries. Dictionaries are key paired or key value sort of mappings. The containers where you can have, so say you want to do something like this, you sort of want to have edges, student edges. You can have the name of the person and then you assign them the edge. Right? So you have this key and then a value, key and then a value. So you can sort of have, if you have data that you need to store in this sort of form, a dictionary tends to form a good way of doing that. Also, you can access it faster, right? So if you want to search through a dictionary or index of items of a dictionary, it's much quicker for searching. So this is, so let's get a dictionary going. So it uses curly brackets. Are these curly brackets? These are curly brackets. They're braces. Yeah, they're those things. So you can have, it's slightly different from a list, which has the square sort of brackets. So that is John, he's 23-year-old, you know. Shira, how old are you? Shira is just 18 years. You know, we can have ages of, I mean, you can do anything, and then you can, it has, again, you can sort of look at what you can get with a dictionary, and I would really encourage you to sort of do this a lot of the time. It gives you an idea of what you can do with any sort of data structure. So things like keys. Keys are sort of the, and then the values would be these sort of the values. Are we here? Has anyone written a dictionary? Anyone lost? Okay. The other stuff, you have some other data types or data structures. So you have tuples, which are immutable containers, immutable things, so you cannot change the contents of a tuple. And those come with these sort of brackets or braces. And then you have sets. So a set is basically it gives you the unique values in any sort of structure or container. All right, so the good stuff is here. So control flow, any sort of language uses exactly the same thing. So Python is unique in that it doesn't have the braces that are common in other languages. What it does is it maintains a space. So you need this space here. That's how it sort of manages scope of things. And so this space is the most important thing. If you mess it up, then it normally complains, gives you an indentation error. Okay. So you need to put that space there, and you need the colon here, the full colon there. All right. So what can you do with a for loop? A for loop is pretty easy. You can either do it like this. So for I in names, print I. So this will iterate or loop through names. So names is this sort of list. So I can loop through the different names in the list directly, like this. Alternatively, I could use this thing called range. So range, if I say range, for example, 5, it gives me numbers from 0 up to, give me 5 numbers from 0. So if I write this range length names, so length names gives me the length of the list, and then I get a bunch of numbers, and then I can print the number, and then I can index on that number, right? So you get something that looks something like this, right? So you get a tuple with the index. So Alex is sort of 0 and his name. Right? So you'll find that sometimes you need to use this range function or method. You can also do this separately. You can use this enumerate sort of method, and gives you the same thing with less hassle. So enumerate basically gets the index and the object or the item in that container. So you get something like this. All right, and you also have if-else loops. It's again straightforward. You can do a comparison. Again, the space is the most important, and then this full colon is what sort of defines things. So we don't have any sort of braces in Python. But you have this full colon. So it will appear on all sorts of things. Even when you define a function, you have this full colon. And you can have this sort of if statement, if-else loops. So if the condition is true, this is printed. Else, so if you do 20, so it will compare this. Then if this fails, it goes to the if-else, and if this fails, it sort of prints else, gives you anything else. And you can do more loops. You can add, you can have loops within loops. So if you run this, it's not necessarily a loop, but you can also have a check. So you're looping over all the names in here, and then you're doing a certain check on, if the name starts with A. And this could be, maybe you're scrolling through a bunch of data and you want particular types of data. All right, so I'll just pause here for a while and let people sort of write some of these loops here if I've not already written them. Anybody challenged? Okay. Right. So you can, yeah, I talked about splitting. So you can split a string. So this split command can be used to split things like a string. So if you have a string like this, the first thing will split it by the space, but you can also split based on a particular identifier in your string. So for example, if we split this whole thing based on this, then it sort of gives you a list of two things. So it splits it here, gives you this and this, as you can see. So this is useful if you're reading in data that's maybe text data and you need to process it somehow. This tends to be quite useful. Yeah. Extremely. So if you had to print a particular word like extremely, how would we print a particular word like extremely? If we had this sort of list string, how would we print extremely? Would? Yeah. Right, so you can put square brackets after, and then you can index it. So 0, 1, 2, 3, and hopefully you'll print extremely. Right? So you can combine these things like this. So you can index it, or you can do a check for whether it, So you can. So one other thing you could possibly do is do things like list comprehension. So list comprehensions are sort of lists. You can process a list and return a list in one line. So ordinarily you'd have a for loop, maybe to do something like this. So in this case, we want to get all the names in names. Let's see what names is. So we want to get all the names here and then change them to lowercase. So one idea would be to write a for loop, for naming sort of names, convert it to lowercase and return it. Or you could do something like this, which is called the list comprehension. So you have whatever processing you want done, and then you loop over each of the elements in the list or in whatever container it is you run. So for name in this, do this function, or do this arithmetic. And so you get the same sort of thing. So this list comprehension is just a short condensed way of writing a for loop. If you have to loop over items in a container, like a list or a tuple, a dictionary. All right. Yes. Yeah. Not sure. Where does the order get swapped? Anyone know? Computer prefers Peter. Yeah. Yeah, could be. Yeah, consistent order. All right, anyhow, if you wanted the things ordered in a certain way, of course you could do a for loop, have them ordered. For loop would definitely give you the same order, or you could sort them. All right, but generally I mean, you could, so this Jupyter is good for sort of running commands in cells. You can sort of write a whole sequenced bunch of commands. Alternatively, you could also write functions. So functions are good if you want to repeat a certain task, you want to repeat a certain computation. And so the functions in Python are basically defined like that. So you have this keyword def that sort of declares function. And then you have the function, and then you have these parentheses where you can put arguments. And you can have a simple function like this. And then you can call the function directly, and then to give you whatever you wanted it to give you. And you can have simple functions, you know, add two numbers. If you want to return something from the function, then you have to put this keyword return, and then to return whatever you wanted to return from the function. So functions have different scope. They have an internal scope. So a variable defined inside here will have a scope that's only that's only relevant in this function here. And so you can do things like this with our function. Oops. There you go. So this is how you'd sort of call the function. And I'm just printing out the result here. So functions are just getting any code you want and putting it there and then returning some sort of. The key thing is it has to have this full colon, and you have to maintain this space. As soon as this space is messed up, then the function, you'll always get an error. And so you need to indent your code properly. So if you had a for loop here, then you'd sort of need to do an indentation there as well. Right? So you keep indenting if you have loops or different scope in your function. All right, and so generally you have modules. So you can have a bunch of functions that you can put in one file, and that will be called, you know, module. You can have a script that runs some sort of thing, and you can create modules or packages. So if I have a bunch of functions I've written in a certain file to help me do repetitive tasks, I can make that a package, or, you know, a bunch of modules, or a module. And so you have this standard sort of modules that come with Python, and they do all sorts of things. And the way you call them is you need to import them. You can rename them on importation, and you can do all sorts of things. And again, the same. So so in the Jupyter Notebook, if you do the Shift tab on any of these methods, you can sort of get. So if you do a dot and Shift tab once, you get some sort of brief description of what this module does. If you do a Shift tab twice, you tap it twice, it gives you more information. If you do it 3 times, it gives you even more information. Right? If you do it 5 times, it will write itself for you and send an email. So good stuff there for you. So it's really good, because if you're sort of writing on your code in a text editor, for example, then you don't have this capability of sort of seeing what methods a particular package can give you. But with this, you can sort of see all the methods you need and sort of pick on them, even with an explanation and examples. So it's all good stuff. You can do things like the mean. I'm using this module here. Right. So you'll find that generally in in the data science work that you'll do, this sort of Python programming language is leveraged by all these packages. So people have written all sorts of packages that you use that make it so easy to do a lot of the tasks that you want to do. Like the whole machine learning thing that I was talking about, you can use something called sklearn. I think Martin will talk about this, or someone will definitely talk about this in this data science workshop. You have things like matplotlib for plotting, NumPy for doing numerical functions. You have pandas. You have all sorts of packages that you can import. Basically import them like this and use them for whatever you want to use them for. So we'll look at NumPy, which is sort of a key package for doing numerical processing. And basically you can take a list, so it allows you to create arrays or multi-dimensional arrays. And this is normally what you want to do because your data is normally structured in some sort of multi-dimensional array. Right? You have some sort of features and examples of the features, and this tends to be in an array. So the normal Python can't handle this as efficiently as NumPy can. So to create you can take a list, and from this list you can sort of create an array just by calling that function there. Or you can do it directly and give you some sort of thing like this. Right? So normally your data looks something like this. You have maybe features, age, height, I don't know, weight, etc., and then examples of different examples of the data. Maybe different people you're collecting this data from. So it tends to look like this. So NumPy gives you the ability to process it in that form. This is very hard to do with plain old Python. And it also has several sort of, you can do things like shape, gives you the size of the array. So this is a 3 by 4 array, and it's a 2-dimensional array. Right? So shape is it's good to know the size of your whatever data you're using. And NumPy also gives you the ability to create all sorts of fake data, or to, not necessarily fake, but you can sort of so for example, you can, this is the range thing. NumPy has a range thing. It starts with a range. Gives you a NumPy array. You have this linear space, so you can create sort of data. I want 15 points that start with the minimum sort of as 0 and the maximum as 10. And I want 15 regularly spaced points in there. This is what this function sort of does. Or you can have ones or zeros. Right? You can get this sort of output from these methods of NumPy. And you have this random, so the random sort of class is very important. You want to create random data of a certain distribution. Yes? Yes, dimensions of the data. So for example, you have this method here, n dimensions, number of dimensions. So the dimensions of the data, and here you have sort of 2 dimensions. You have, I guess with arrays, you can think of the dimensions as this is 1 dimension and this is another sort of dimension. This would be 2 dimensions. All right. So NumPy has a method called reshape. So it can allow you to reshape your data to any sort of factor of this, so if I had 16 sort of things, I can say I want it to reshaped into a 4x4 array. Or I can say, 16, I could have a 2x8 array. Or I could have a multidimensional thing. So a 2x2, which is 4 by 3. No, 4. And then I'll have, so this would be a, let's call this G. And you can sort of look at G and also the number of dimensions G has. So G has 3 dimensions. So these are the 3 dimensions. You sort of have a 2x2 4 times. I mean, it's hard to see, but you sort of have, this is 1 dimension, this is this. No, wait. Yeah, I guess it's hard to see from here, but you sort of have. You have a multidimensional What did you guys study in the morning? Huh? What did you study? It's unclear. So you sort of have these sort of so this would sort of be 3 dimensions. You sort of have a dimension, a dimension, a dimension. You could sort of look at them like that. Right? That you have some other. So our array there is something like a 2 by 2, and there are sort of 4 2 by 2s, 2 by 2 by 4. Hmm? Two by 4. It's easy to find out. Well, so you can sort of, as I said, you can sort of look at these things, and if you press tab long enough, you can sort of get, oh well, no, this one doesn't have much documentation. Anyhow, you can sort of reshape these arrays in well, okay. All right, let's continue. All right, so you can also do indexing. So you can do slicing and indexing. So this you'll find is something you'll need to do several times or when you're dealing with data. So this is probably the same. There's another way you can create data using random. So this creates sort of random integers. You can see what the data looks like. So I'm creating some sort of children's data. I think if you assume this is the age and this is the weight, I just created the data is from 1 up to 10, and the size is 4 by 2, so 4 by 2. And you sort of have labels. Imagine this was male, female, etc. And you can do things like this Boolean stuff, and you can use this to index. So you can index based on some Boolean function. So for example, here I wanted to get only the male children, who are the, the data for the male, sort of, for the boys, or for the females. So the females are these two. So you find you do this quite a lot if you're sort of dealing with data. All right, and then you can do things like summation across the different axes or the different sort of dimensions. So if you have, if that is if your data looks like that, you can sort of sum up. So axis 0 is basically this axis going down. So you can actually sum up these things here across the dimension, across the axis here. Or you could use axis 1, and then it will be summing up the rows. So different ways of getting. You can get averages. Alternatively, you can use internal functions in NumPy. Get the mean across different axes. So this is exactly like, well, slightly changed. Oh yeah, so here the mean is this mean is different from this mean. Does anyone know why? So I'm doing exactly the same thing. I've sort of calculated the data down here and divided by the size of the data, and I'm using NumPy here to do this. Anyone know why this is different? So integer division, right? So Python. So I'm using this version of Python. I'm using is 2. Actually, I should change it to 3. So in Python 2 and 3, this sort of changes. Up to Python 2, you didn't have explicit conversion, right? So if you divide anything by, if you divide any two numbers and it didn't explicitly say one of them was a float, then it converted the thing into an integer. But with Python 3, well, in NumPy does that for you automatically. In Python 3, this, let me see. Okay, now I need to, once you change the kernel, then things all get changed up. So I need to run these things again. Right. All right. Now with Python 3, it sort of works out automatically. It can handle this sort of thing. It was something that was problematic in Python 2. If you didn't remember it and you did a lot of data stuff, then it sort of messed you up in the end if you didn't take care of it. So you can sort of go to this link for more stuff. Maybe the thing I wanted to talk about, I hope people are sort of getting there, is sort of dealing with data. So most times you have some data in a CSV or an Excel file that you want to sort of process. So you need to read it in and take a look at the data. So one way to read it in is just to use the normal Python. So Python comes with a way to open any sort of file and read lines. So it has this, you can use the keyword with, or you can just say f is equal to open, blah, blah, blah. But this tends to be the way to do it. And why do we do it like this? Because this automatically closes the file when you open it, right? Once you're done processing, it automatically, otherwise you'd have to say sort of f is equal to open, then you have to say at the end f close, f dot close, to close that, close it up. All right, so you can, so there's a data file in your folder, should be somewhere there. So this is data we got from Open Data, Open Data. So Kenya has an Open Data initiative where they put all this data. So just got some few data from there on Kenyan schools. All right. Oh, the R parameter is read. If you wanted to open a new file to write, you could sort of put write. R means open the file for reading. And then F here is basically read lines, read all the lines in this file. And so you can, if you wanted to see all the data read, it sort of looks like this. So it returns a list of all the lines in the file. So not interesting stuff. But you can slice it and say I just want the first sort of two lines in the file. So you can see this file has, it's sort of a file has name. This is sort of the header file, the header of this file, and then for each of these items it has numbers here, right? So for example, the school code is this, the name of the school is Ngozi, etc. The address is this, etc. And you can sort of do other stuff. So here I'm splitting the so here I'm sort of taking the first, so I'm taking the first, so it gives you a string for each line. I'm taking the string for each line. I take the header, so the header is the first line. So this read line is different from read lines. Read line reads one line at a time. I'm just splitting that and taking the first, from the 3rd to the 10th, 11th sort of feature, and then appending that to a list, and then just returning that. And so that looks something like this, basically. This is the header, and these are the schools. Now they are more legible because I just truncated them. And you can do also, you can convert it to a NumPy array, you can hide the output of a cell, you can toggle it, and then you don't have to see the output which is there. And then you can sort of do, so I wanted to highlight some issues with sort of reading data in like this. So for example, after reading in this data, I may want to, so this data represents, so these are the headers of this data, and I want to read in the total enrollment. Right? The total enrollment is the last sort of figure. So here, for example, it's 58. But when you come down here, for example, it's something else. Right? It's ordinary for some reason. And when you look at so this is the my new data. I'm just taking all the data and indexing by the last column, which is the total enrollment. So I want to see, total enrollment, I want to see the numbers. Say I wanted to get the average enrollment in these records. Right? The problem now is that for some I get a number, for some I get a strings everywhere, but I can convert this into numbers, but this I can't convert into any number. And the reason why this happens is you can see it from the data here. Good. Let me open up the data. So if you open up this data here, so what you see is that, so when you look at something like this, so if you're splitting the data, if you look at what we're trying to do here, is splitting the data by, where is it? So we split the data by this comma. But unfortunately, sometimes you may have data where this is not a very good idea. So for example, this is an address. So this is one address, but the address has a comma. So it's sort of 9, lunga lunga, right? Now when this happens, if you just split the data by commas, ideally it should split here and sort of split here. But this gets split in here. And so you end up having something that looks like the data we now have, like this. So it pushes some of the fields ahead, right? Because it's split more data than you wanted, right? So you get these sort of errors. So one quick way to solve this is to use things like the CSV library. So this one automatically takes care of all these things, right? It takes care of all the sort of splitting. So what it takes care of is, for example, if you have this particular thing where you have quotation marks here, then this should be read as one entry, not as sort of two entries separated by a comma, or something like this, right? So this again would also be split, but it reads it as one entry. These are geocoordinates. And so this gives you a better, if you read it with that, then if you look at the data again, now we seem to be getting what we wanted. So we're getting figures in all the right places. And so you can start from 1 to eliminate sort of the title. You have your figures, then you need to convert them. So you can see these are sort of strings. So you need to convert them into a floating point, a floating number, and then you can use a list comprehension to sort of calculate the mean. So this is the enrollment converted into numbers, this thing, and then this thing here is the sort of the mean enrollment. So this is sort of a very involved process. So you have to sort of go through a bit of stuff to read in the data. But they tend to be easier ways of doing this. So you can use NumPy, but this NumPy is good for loading data which is numeric, right? So for example, this is some data you'll use in the lab. You can index out of range. So this index. So you can. It has several sort of parameters. All right. And if you do a tab on that, you can sort of gives you all the things you can put. So load text in name, the type to automatically converts in, and etc. etc. But this data is purely numeric. If you have data that's not numeric, then this load text gives you some arbitrarily. You sort of have to do things, skip rows, select different columns, etc. But this is one way to quickly read in data if you have data in a format that can be read like this. So this data looks like that. So you have a bunch of comma-separated figures that you can quickly read in and then process. Okay, so the thing I want to talk about was Pandas. So Pandas is sort of it's a very good tool for doing data science. So it allows you to read in data, and the data almost looks like tabular data, or looks like, and it gives you sort of functionality as if you are querying a database. So we can read in our same data using this Pandas, and immediately you see it gives you a better output of the data. Now I can sort of look at the data, see what columns are there, see what it represents. Oh. There you go. So Pandas gives you this nice ability to read in the data and you can also just, so the things we've been fighting with, getting the total enrollment by indexing, here you can just sort of get them straight away. Right? I just call, this is the header of the file, so total enrollment, and then gives me everything. I can calculate the mean immediately. I can read in all sorts of files, so you can read in JSON files, you can read in Excel files, you can read in any type of file, and still give you the same thing. So it returns, the Pandas returns always a table of data like this that you can sort of look at. You can select different rows or columns, etc. All right, and the sort of the final thing is on plotting. I don't know if I've, yeah, so my plot. So let me just change. So you can do plots easily. So this sort of thing here is called magic commands. So this one allows you to do plots inline. So you can do plots within your notebook. B is not defined. So you can do all sorts of, you can do plots with Matplotlib. Also, Pandas gives you the ability to do plots directly from Pandas, right? So it does exactly the same sort of thing. You have different types of plots, histograms. You can do a scatter plot, for example, trying to understand the relationship between total enrollment and total teaching staff. You get some sort of, so you can do plots quickly, you can save them, So with lots of stuff you can do with Jupyter and Python and the accompanying libraries. All right. So this is basically it. So it gives you a short tutorial if you've sort of gone through it. I hope you have the notebooks now. Yeah. Is anyone without a notebook? Sorry? Oh, I thought. So do you have this actual notebook? Oh, I thought it was one of the time. All right, so yeah, it's on the, oh yeah, he's going to come and explain how to get it.
Hi all, quite to connect to Data Science After DFA 2017, the Wi-Fi.
What's the solution?
There you'll be able to download the notebook, especially the Martin's one when that's here. You'll be able to download that too. And if you have trouble running Jupyter on your laptop, you can also try out running notebook on our computer as well. So, thanks, everything. Yep, that's it. Does that work? No. What goes wrong? How do you show that? Can you show me how you search for Wi-Fi? DFA 2017, just that one? Yeah, that's it. Okay, cool, and open. That might be Nobody confident. It worked a few seconds ago. Oh no, there it is. Right, okay, so there's some stuff about installing things. You can download Anaconda here if you haven't got that yet. And then some instructions. And then here it's got, somebody's just got Ernest notebook. You click on that. It'll give you a zip file eventually. You can download that.
Yeah, the first one. Oh, yeah, it opens it up. I know it opens it here.
Oh, it's opened it on the screen. Right.
Yeah.
There you go. So, does that work? Everyone? Good. Right. Cool. So you should all be able to download those files. And that's where you can go for the next few sessions and things. Cool.
But you can only do this here, I think, right? You can't do this in your hotel. You can only do this here, so make sure. Yeah, it's hosted here.
When I get on the internet, then I can just get onto GitHub. I'm not using
Ah. All right. Yes, Isaac. Mike, question for you. All right, so in the Yeah, so please do this. So in the practical session later in the afternoon, you will sort of be going through this other notebook which has a lab on it. So it has a bunch of stuff, a bunch of functions you may need to sort of fill out. So you need to sort of write some code in here and a bunch of things basically. So some of them have questions, and then we'd also try and build sort of a classifier based on partly what Neil sort of talked about from scratch. So splitting the data and training test label, sort of coming up with prototypes. So it's a very basic sort of classifier, and then doing some classification, and then some data set you need to import with pandas, and then do some sort of analytics with it. So this is partly what you'll do in the lab after lunch. All right. Any questions? Yes, sir. Right, so with Python you can develop, you can do scripts that run jobs like the one we're doing here. You can build web applications. You have things like Django or Flask. These are frameworks which you can use to build an application on the web that can do processing in the back. You can do, web. There's been some trial to do things like running Python on a mobile device. But I don't know if that's been very successful. But you can build any sort of application you can build with any other language apart from mobile applications. I don't think that works quite well. But any other thing you can do. The versions, well, now we are in version 3. So version 3 is slightly different from version 2. But in between 3, 3.5, 3.6, they are all more or less the same. By any sort of conceivable thing you can think of, you can probably do it with Python. Yeah. Yes? Oh, the IDE. So you could let me try and so in you can in Spider, in that Anaconda comes with an IDE called Spider. I think it's like that. And Spider, if you just run, if you click on Spider, you run that command, it comes up with this IDE that you can use. It looks something like this. And so you can sort of write your code here and run it, and then it will appear here. Then you can sort of see all other things. So if you're used to running things in an IDE, Spider is one of them. So it has, and you can run scripts directly here. Write your code here, you can save them as files, etc. Any other question? All right. All right, if there's no other question, then we can sort of break for lunch. Please download those notebooks, go through them. if Python is something you're sort of getting used to now. And then go through the practical at the end, give you some insights on what to do with data. Okay. Thanks a lot.